properties or characteristics. And this is in my notes, so you really don't have to write it all out. And I can't promise I've got it word for word from in the notes, but just as I remember it. These are properties which we can observe or measure, and it does not change. And what I probably should write out, and when we observe it or measure it, it does not change the composition of the substance. I think a really nice word to help you remember this is to say non-destructive. In other words, when you do this to it, you observe it, you measure it, it's still the same stuff. You haven't destroyed the stuff and turned it into something else. You can't really destroy stuff in ordinary experiments. That conservation of matter, you start with so much, now it may not end looking the same way like the sugar. Okay, you got so many grams of sugar. If you decompose that sugar by heating it really hot, then you got carbon and you've got water vapor, and together you would have the same amount of stuff. It's just in a different form. So conservation of matter. So physical properties. Okay, if I hold this piece of magnesium ribbon up, and one way to buy magnesium is a spool of it, and it's ribbon. It's a metal, and if I were to ask you, I want some physical properties of this thing, and that means non-destructive. So what could we say about it? It also, I want to add something else, doesn't depend on amount. Doesn't depend on amount. Erin, what could you tell me about this? It's silver, so you can tell me the color. That certainly doesn't hurt it. Bruce, what else could you tell me?
It's thin.
Well, now that depends on amount. I could buy it a thicker width to it. I could buy chunks of it. So you've got to be able to describe it so it's the same wherever we get it. And it doesn't depend on the amount that we have, whether I have this little piece or I have a warehouse full of it.
It can be bent.
Ah, okay. It's soft. So softness or hardness. If you've taken a geology class, they talk about a hardness scale. Like one part, can you take your fingernail and cram into it and make a dent? So softness or hardness, whichever. Okay? Also, it's malleable. I can change the shape of it. So that's a nice word that kind of goes along with hardness and softness. Okay, malleable. Okay, I can do this to it. What else about it? What else about it? What could we say? Tanya, what would you say? Okay.
The melting point?
Very good, because I could melt it, and if I do this gently, I could melt it, get it in a liquid state, then I could solidify it and get my mercury back. Or not my get my magnesium back. So melting point temperature, because that doesn't destroy the fact it's mercury. No, it's not mercury. It's magnesium here. Okay, then if you say melting point, does that make you think of another? Boiling point temperature. Boiling point temperature. Those are good. Any others here?
Freezing point.
Freezing point or melting point and freezing point's the same
Cobra
thing.
speed.
It depends on direction you're coming from, which you call it. But yeah, that's good.
Conducts electricity.
What's that?
Conducts electricity.
Okay, now you might think, does it conduct a current of electricity? And you think, oh, electricity is dangerous. That doesn't sound real physical. But think of the copper wiring in your home. That conducts the current of electricity and has been doing it probably for years and years, and you hope for a lot more years in the future. So that it conducts a current of electricity is a physical property. It doesn't destroy it. That flow of electrons just moves through it. So, conductivity. And actually, can you read my writing there? It's in the notes, and you can't read my writing. Conductivity, actually not just of electricity, but of heat as well. Like metals tend to conduct heat really well. That's why on old-fashioned stoves we got metal pots and pans, because they conduct heat so well and you can heat stuff up fast. What about odor? If I wanted to smell the same, how would I smell it? Remember proper procedure for smelling? Even though it looks pretty safe. Yeah, you want to waft it too. Okay, did that hurt the magnesium? No. So odor. Now, if you're a biology major, you may say, when you smell things, there's this complex chemical reaction going on in your nose, sending signals up to your brain, and you go, oh, that smells good, that smells bad, and you make a value judgment. Or, hey, that smells like my dog, or whatever. But the odor doesn't hurt. By taking the odor, by smelling it, that really doesn't hurt it. Even though I said you got to have a few molecules up your nose to smell it, that's not a big enough loss. We're going to worry about it. And of course, this has no odor. Okay, so those are some of the physical properties of this magnesium. Now, I want to move into chemical properties, and I'm going to do something I used to hate teachers for doing. I'm going to make a minor change, or changes in this, and if you want it, you got to read out the whole thing, but hey, it's in the notes, you don't need to. Okay, what are chemical properties then? These are properties which we can observe or measure, and it does change the composition. Okay, so that means it is destructive. We've turned it into something else. Okay, so, and it still doesn't depend on amount. So all of these things were examples of physical. Now let's think chemical here. When you do something chemical or you see a chemical property, it's drastic. You don't have your stuff anymore. Could you think of anything that we could test this for?
Energy.
What?
Energy.
How much energy content it has.
Well, maybe if it wasn't.
I think you may be getting toward it. What does paper do? What will paper do?
Burn.
Burn. So you can always ask, will something burn? Of course, and if you find out it does, you've lost your stuff. Okay, so that's destructive. So burning, hey, that's good. Will it burn? Okay, let's find out. Okay. I'll do at least this much for safety's sake. And I'm going to hold it because I happen to know what's going to happen. Okay. All right. Now, let's do this. I want to light the burner, and I want you to tell me if I've done it the right way. Okay, remember your safety lessons? I'm going to use a cigarette light. I hate those strikers we have in the thing because you're going scratch, 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 and it drives me nuts because I know your burner, your gas is going. I'm thinking we're going to blow up here. So I like to use a cigarette lighter or a match. So I'm going to do this and turn the gas on. Now, was that the right order to do that? That was one of the quiz questions. Yes, it was. If you're using a lighter, now I know the lighter part wasn't on the quiz. If you're using a lighter or a match, do it first. You are never going to forget that this is in your hand. But if I just turn the gas on, I could start talking and forget I had the gas on. And so do this first, then turn your gas on. Of course, if you're using a striker, you don't have an option. You've got to turn the gas on first and then go scratch, 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 and hope you get a spark. So I would bring a lighter to put in your drawer. It would be really handy, or bring matches to put in your drawer. Okay, let us see if a property of magnesium is that it will burn.